Fifth graders, today is Wednesday, February 5th, and we are continuing on in Module 4. We're doing Module 4, Lesson 3. And you can see that our learning goal is actually the same as yesterday. Yesterday we proved to ourselves that fractions is just division. The numerator is the whole, the line is the division sign, and the denominator is the divisor, right? Today we're going to continue exploring this idea of fractions being division, and we're going to see how we can deepen our understanding about this concept. Okay, here's a scenario, and we're going to draw a picture to represent it, okay? It says a baker poured 4 kilograms of oats equally into 3 bags. What is the weight of each bag? So if we draw a picture, we know that all together, how many kilograms of oats do we have? 4 kilograms. And I want to divide it equally into 3 bags. Here's one bag. Here's the second bag, and here's the third bag. We want to find out what the weight of one bag is. Another way we could draw the picture is I could show you that I have 1 kilogram of oats, another kilogram of oats, 3 kilograms of oats, and 4 kilograms of oats. And each one needs to be split into 3 so that my first bag can have this third, and this third, and this third, and this third. My second bag can have this third, and this third, and this third, and this third. My third bag can have this third, this third, this third, and this third. Do you guys see that? That's like what we did yesterday, right? So how many thirds could go into each bag?
3 thirds.
How many bags? If there was a blue bag, a red bag, and a green bag here, how many thirds are in the blue bag?
4.
How many thirds are in the red bag?
4.
How many thirds are in the green bag?
4.
So if I have 4 kilograms altogether and I want to divide it into 3 bags, how many kilograms are in each bag?
4.
Yeah, there's 4 thirds in this one, 4 thirds in this one, and 4 thirds in this one. If I want to color code it to make it match up with my, drawing over there, I could do it like this. I could say that in the blue bag, there is 4 thirds of a kilogram. In the red bag, there's 4 thirds of a kilogram. And in the green bag, there are 4 thirds of a kilogram. Okay. Now, what if I want to use, what math problem am I doing here? I have 4 kilograms, and I'm dividing it equally into 3 bags. So that equals 4 thirds, which is 1 and 1/3 kilograms. What if I want to use unit form? Right now, my units are 4 ones. But because I'm dividing by 3, I want to change it into,
4 thirds.
would it be 4 thirds? How many thirds are there in one whole? How many thirds are there in one whole?
3.
So how many holes do I have though?
4.
So how many thirds are in 4 holes?
12 thirds.
So this is the same thing as 12 thirds divided by 3. What's 12 divided by 3?
4 thirds.
4. What kind of units are we using?
Thirds.
So you can see by using unit form, using pictures, and using numbers, we get the same answer, 4 thirds. How can I use inverse operations to check my work? Well, remember, what's the inverse of division?
Multiplication.
So if I did division this way, I could do multiplication this way to do the inverse. So that means I should do 4 thirds times 3, right? Now we haven't learned how to multiply fractions yet, but we know that multiplication is the same thing as repeated addition. So instead of saying 4 thirds times 3, how could I write that using repeated addition? I could say it's 4 thirds plus 4 thirds plus 4 thirds. Do you guys agree? If I have 4 thirds and I add 4 more thirds, how many thirds do I have?
8 thirds.
And if I add 4 more thirds, how many thirds do I have?
12 thirds.
So this is the same thing as 12 thirds. Is that an improper fraction?
Yeah.
Yeah. 12 thirds is equal to 4, right? This is equal to 4. If I go backwards, is that my whole? Do I end up with my whole? So I can use inverse operations to check my work. We can see here that we have a chart, okay? And in the column going sideways, it's going to be the same value. We can write the same thing in many different ways. We can write it using a division expression, which is right here. 5 divided by 4. We know it's a division expression because, boom, there's the division sign. Okay. We also know how to write it using unit form now. What would the unit form be? Well, instead of ones, we know that we want to write it using. So 5 ones is the same as how many fourths?
24.
So how would you write this using unit form? In your notebook, go ahead and make the same chart. How would you rewrite this problem if you know that 5 ones is the same as 20 fourths? Well, it would be 20 fourths divided by what? 20 fourths divided by 4. And then to make it complete, you would write the equals, equals 5 fourths. Okay? So now you can write the division expression. You could also write it using unit form. How would you write it using an improper fraction? Well, what would the numerator be? How would you write this the same expression, 5 divided by 4, as an improper fraction? What's the numerator?
5.
What's the denominator?
4.
Is that an improper fraction? How do you know it's improper? Very good. Okay. So you can also write it as an improper fraction. Once you've written it as an improper fraction, you therefore also can write it as a mixed number. How do you write 5 fourths as a mixed number? How many wholes are there in there?
1.
And what's left? 1/4. Good. Then you can also write it using the standard algorithm. Remember, the standard algorithm is when you have your whole in the house and your divisor knocking on the door. So which number is living in the house? Everyone? 5. And who's knocking on the door? Okay. So you can see here that we started with 5 and we divided it by 4 to get 1. Then we sister subtracted 4 and we ended up with 1. You write your remainder of 1. Instead of writing R1, I could take that 1 and divide it into 4 equal parts. When I have 1 remainder and I divide it into 4 equal parts, what's 1 divided by 4? 1/4. So as you can see, you need to write your remainder as a fraction, 1 1/4. Okay. Then you can check your work. What multiplication equation would we do in order to check our work here? Anurag? 1 1/4 times 4. Very good. 1 1/4 times 4 is the same as 1 1/4 plus 1 1/4 plus 1 1/4 plus 1 1/4, which is the same as 1 plus 1 plus 1 plus 1, or 4, plus 1/4 plus 1/4 plus 1/4 plus 1/4, which is 1. So 4 plus 1 is 5, and that's what we want to end up with. So this chart shows all the different ways you can express the same division problem. Does that make sense?